Every farm is dealing with the same pressure. Finding labor is harder than ever, equipment costs keep climbing, borrowing more money feels riskier, and harvest windows don't get any longer. So when we talk about forage harvesting, the real question is not what system is fastest or what system did my neighbor choose. The real question is what system deliver feed at the lowest real cost with the least people and the least financial risk. And that is why we built that simulator. The problem with most comparison, for years the conversation has gone like this. One self-propelled chopper versus one baler, and the conclusion is always the same. The chopper is faster, baling can keep up, bales are a headache to move, but the comparison is flawed from the start because no one will ever say one chopper replaced one tractor. And yep, that's exactly how baling has been judged for years. We ask ourselves a simple question. What happens if every system is sized to harvest the same amount of dry matter per hour? And this is what the simulator is about. So the way it works is really simple. You're gonna get on the top part of the simulator what we call the general parameter. So you can switch from first of all imperial to metric system. So all the numbers going to change automatically. You have your wage of the operator. So let's put it up to let's say 25 bucks an hour ish roughly. You put your diesel price, interest rate, the average distance from the field to the storage site, and then here we have the grass yield and dry matter per acre, and the yield of the corn yield of in dry matter per acre. So that's about 8 ton of corn per acre of dry matter and about 5 ton of grass per acre of dry matter. Once we have that set up, you can reveal basically the capital cost of equipment. This is where we put all the cost of tractors per horsepower. There is four categories for the tractor. You can also modify the lifetime of each tractor. So for the simulation purpose, they are all set at 10,000 hour. And also, what is the amount of hours you're going to use that tractor on a yearly basis? That is used to calculate the depreciation and the ownership cost over the years. And then you got at the end the salvage value at the end of that 10,000 hour. What is the tractor worth? Same for the forage harvester, self-propelled forage harvester. It is set at $1,400 per horsepower with a 6,000 hours life expectancy. And then on the right side, you're gonna get the implement cost, so capital cost basically. These figures are not representative; they're just there for simulation purpose. If you don't agree with that, you can change this number as much as you want. This is why the simulator has been built for. Once you have your capital cost of equipment sized up, you can go into the earned size, nutrition, and losses. So here you're gonna say how many mama cow, basically you have on your farm, and you already have the amount of kilos of dry matter per day per cow that each of them is gonna consume, and you can change the percentage depending if your your cow is not exactly as it is on the spreadsheet. You can change that. What's going to give us at the end is the amount of tons that are needed as fed to feed this amount of cows over a year. All right, so that's basically what we're trying to achieve. And then we have here the losses by technique. So if we do, for example, baleage, so we wrap bales, these are the losses that have been backed up by several studies. So harvesting, storage, and feeding losses, and the same for bunker. And then we ended up with these numbers. So once we're done, we can just scroll that up. And so here we're going to compare five system. I'm not going to talk about the pull type forage harvester, so I can just hide it here. So basically we are down to four systems that we can compare side by side. Now let's talk about number, not theory. In our example here, I'm going to set 500 cows with about 250 heifers and 250 calves with the consumption per head per day. The cornerstone of that simulator is the corn silage. So when I start with it, I'm going to set how many horsepower my forage harvester has. So 720 horsepower in that simulation with 70% moisture on the corn and 10% inefficiency. So that's I wrote 90% efficiency. So one chopper is going to harvest 77 ton of dry matter. That's 78 ton of dry matter of corn per hour. And then we size how many baler do I need. So with the old baler, if we go on the left hand side, back then you could run a baler with 120 horsepower, generate about 40 bales per hour, and these balers were about 1,400 pounds each with a 50% moisture and let's say 90% efficiency. In order to be able to produce at least the same amount in the corn chopper per hour, I will need 7 balers running out in the field, right? And then I will be at 88 tons. If I'm putting down to 6, then I'll be less than 77. But we want to compare is the baling system is able to keep up and produce the same output per hour than a corn silage setup, right? So once I have find out how many balers I need to equal corn, then all the step below, so hauling the crop to the storage area and wrapping it, or in the corn silage simulator, for example, how many dump bucks do I need so my harvester doesn't stop. So based on that distance we set up earlier before on top, so at 2 miles, with a 200 horsepower tractor, 2,000 cubic feet dump box, and a loaded speed and empty speed back, I'm gonna need about 6 tractor to just move that crop from the field to the bunker nonstop, right? And I do the same here on the whole balage system on the left hand side of the screen. If I use the old system, which are like typical pull type wagon, 150 horsepower, let's say 10 bales of silage per wagon, so that's going to be 20 bales per trip. I'm going to need about 8 tractor and platform to be able to move all these bales produced by these 7 balers, so the balers don't stop, because we are putting the same restriction on the balage system than the corn system, because the corn system everything need to be synchronized, and this is what we want to see what the results going to be. And then here at the bottom, we have the storage. So we have inline wrapper. So one inline wrapper with 120 horsepower tractor front end loader. You're going to be putting bales on it, and it's going to wrap about 130 bales per hour. You set your film cost, and then basically what it says here is you're going to need two inline wrapper to be able to wrap at least 88 tons per hour. So at 2 wrapper, I'm good with 91 tons of dry matter per hour. That's going to be wrapped, right? In case of the corn silage system, if we go back here, so we set the tractor horsepower, and the tractor horsepower will basically calculate approximately the weight of that tractor. So the weight is calculated, it is about 85 pounds per horsepower. And then the compaction rate, you need about 800 pounds of tractor weight per ton of dry matter per hour. So if I increase the horsepower, if I put 400 horsepower tractor, then my compacting capacity will be 85 ton of dry matter per hour. So you can change all the numbers and everything's going to be automatically calculated, right? So this is old balance system versus current silage system. And then if you want, we can look now at the new balance system. So what I call the new balance system, it is high density round baler. Over the last 10-15 years, equipment manufacturer has done a tremendous job improving round baler performances. Of course, they came with a higher horsepower requirement. So in this cases, let's say 150 horsepower tractor with a little bit higher output, but a lot more tight bales. So the bales, instead of being 1,400 pounds on the left, they're going to be now 1,800 pounds. Same moisture, 50%, same efficiency, and I'm down to 4 baler. 4 baler today will be able to produce the same amount of dry matter per hour than a 700 horsepower forage harvester. We go to the hauling system. So instead of using typical farm wagon, we're going to use a self-loading bale carrier. So again, 150 horsepower tractor with a 14 bale capacity. With the load speed, empty speed, you can change that as well. With 4 tractor and self-loading bale trailer, I'm going to be able basically to transport all the bale that were produced by the round balers. Of course, if I increase the distance, if you remember, if I go on the slide on top, if I increase the distance from the field to the farm, all the number change. And then for the corn silage and with my baling system, the numbers of trailers needed are just going up. I have the same tractor than my old baling system, 120 horsepower front end loader with 130 bale per hour capacity per wrapper. My FIM cost again about $3 per bale. It's slightly less than that today. I'm gonna need two wrapper again. Now you might ask, why do you have a higher fleet capacity per hour versus the old system? The only difference is the bale density. So the bale being tighter, I can still wrap 130 bales. That hasn't changed. But the bale being tighter, I have more pound of dry matter per bale. That is why my fleet is going up here. So, and then at the end, we are getting three interesting information. So first of all, it will calculate, if everything has to be done in the same day, like it is required for current silage system, how many equipment and capital costs as new would I need? So the old balage system was about 5.4 million, 5.5 million, and it will require 17 people at once in the same day and during 36 hours per season to do the harvest. If I go on the the corn silage will require 10 person to be able to do that with a $5.7 million investment in order to be able to do the crop in 47 hours per season. And with the new balance system, I'm down also to 10 people, same as corn silage. I have the same output per hour, but I have 3.5 million in capital equipment as new for 41 hours. So just to open up your eyes on what a new balance system could achieve today. Below, you're going to get the comparison. So how many gross ton of dry matter you need to harvest. So after the storage losses and hauling and everything, all system has 3,000 ton of net of dry matter of feed. And then you have harvesting, hauling, and storage that you can break down and see the split between ownership and operating. So this is what it looked like. And as you will notice, and this is where the graphic is really interesting. So the old balance system, which nobody wants, and I don't blame you for that, but the cost per ton of dry matter was about $41. With the self-propelled grass system, it's $38. When we switch to corn, the cost is going down to $35 per ton of dry matter. And then the new balance is $29. It is the cheapest. It is as fast as corn silage, and as you could see in every system, logistic is the biggest expenses. On a short distance, we were only on 2 mile distance, hauling the crop, this is where it hurts. And why the new balance system doesn't hurt that much versus corn silage and so on. With self-propelled forage harvester, no matter if you do grass or if you do corn, you are not compacting the crop at the field. You're compacting it at the storage site. And therefore, you are moving a lot of volume, which is not compacted. Versus when we go with the new balance system, you can see it was costing us $14 just for our baling. Now it's down to $10 because the balers are more performing better, so they can put up more bales and tighter bales per hour. And then, as you can see on the hauling cost, we're down to $9.3 for moving bales, but I'm moving already compacted, tight bale, and so I don't have that much volume to carry as same as the corn silage system, for example. And this is where the big difference is. So, that being said, I hope you enjoyed that simulator. The conclusion is from that simulator that I could see is balage is overall winner for the grass feed system, and so no doubt about it. When we compare corn silage versus balage, I can't say corn silage is better or not as good as balage. There's pro and cons for both systems. So corn silage bunker, the pros are you only have one harvest versus three cutting if you do grass feeding system. And the corn will provide you a higher yield per acre. So if you're limited In field, corn would generate more feed, so you can basically feed more cows out of the same acre. The cons are that the corn silage, it's a costlier ration. Corn's ration need expensive protein supplement. There's also a single point of failure in the corn silage system. If the harvester breaks down, the entire operation stops during that day. And then also you have a higher capital and debt ratio, so more equipment investment that depreciate, and that doesn't bring any value to your operation. With the new balance system, you have built-in redundancy. One goes down, you still have three baler running, so you're not stopped. Also, one of the biggest advantage I didn't address is it is independent phases. So baling, hauling, and wrapping don't need to be in synchronization. For the simulation purpose, we did everything at once with the same restriction than cord silage system, but in the real world, you don't have to do that. You can reuse the same tractor, so the tractor that we're using for baling, you can use it for hauling, and therefore the capital investment in the simulator is not as high as it was shown. In the reality, it's even less than that. The cons of the new balance system is you have to manage tree cutting. The new balance system is a good way to go for every farm, no matter the sizes. But you can play with it. I invite you to go back to the simulator. You can put your own numbers and see what are the results. So hope you enjoy that. Thank you very much.